Good morning or good afternoon, depending on what class you're in. We're looking at Big Ideas 7.8 in OneNote. So if you need to get to that point, go ahead. 7.8 in OneNote. In lesson 7.8, we are finishing factoring. And we need to make sure that we are thinking mathematically when we are factoring. And that means we can't just factor once and think that it's done. We need to factor polynomials completely. So our learning target for today uh, and tomorrow, 2-day lesson, factor a polynomial by grouping and recognize when a polynomial is factored completely. So we're actually going to use a different system from our X box on this, and that's because many of the uh, polynomials that we'll be factoring will start with more than 3 terms, and X box really only works for 3 terms. So to know that you are successful with the learning target, you will be able to factor polynomials by grouping. You'll be able to factor polynomials completely, and of course, solve real life problems by factoring. All right, so we're going to start here in the Explore It section. Okay, Explore It. This is work with a partner. You're welcome to do that or work by yourself. And it says 5 students are asked to factor the polynomial below. 4x to the third power plus 16x squared minus 84x. And those 5 students factored this way. Student 1 had 4 times the trinomial x to the third power plus 4x to the second power minus 21x. Student number 2 had 4x times the trinomial x squared plus 4x minus 21. Student 3 had 4x times the binomial x plus 7 times the binomial x minus 3. Student 4 has 1/4 times the trinomial 16x to the third power plus 64x squared minus 336x. And finally, student 5 has x times the binomial 4x minus 12 times the binomial x plus 7. So the first thing we're going to investigate here is, are all the answers above equivalent? Explain. So what I'd like you to do, either alone or with a partner, is off to the side. I want you to multiply. Okay, so we're not factoring anymore. These students have factored. Now we're going to check their answers. So we're going to distribute whatever's outside the parentheses. And then if we have 2 binomials like student 3 and student 5, we will we will multiply those by distributing. So pause the video, off to the side, multiply what every one of these students factored and see if they are all equivalent. Pause now. All right, welcome back to the video. For student 1, they had 4 times x to the third plus 4x squared minus 21. Oops, x. So 4 times x to the third is 4x to the third. 4 times 4x squared is 16x squared. 4 times negative 21x is negative 84x. Student 2, 4x times x squared plus 4x minus 21. 4x times x squared is 4x to the third. 4x times 4x is 16x squared. 4x times negative 21 is negative 84x. I'm seeing a pattern. Student 3, 4x times x plus 7 times x minus 3. 4x times x, 4x squared, 4x plus 7 plus 28x. Now again, we distribute. 4x squared times x is 4x to the third power. 4x times negative 3 is negative 12x squared. 28x times x is plus 28x squared. 28x 28x times negative 3 is negative 3 times 8, 84x. Now we have to simplify our like terms or combine our like terms. 4x to the third plus 16x squared minus 84x. Student 4, 1/4 times 16x to the third plus 64x squared minus 336x. All right, 1/4 of 16 is 4, so 4x to the third. 1/4 of 64 is 16, so 16x squared. And 1/4 of 336 is 84, so 84x. Finally, student 5, x times 4x minus 12 times x plus 7. X times 4x, 4x squared. X times negative 12, negative 12x times x plus 7. 4x squared times x, 4x to the third. 4x squared times 7 plus 28x squared. Negative 12x times x, negative 12x squared. Negative 12x times 7, negative 84x. Combine our like terms. 4x to the third power plus 16x squared minus 84x. So you notice that every single one of these students factored that trinomial, and they all factored correctly because when we multiplied them back out, we got the exact same trinomial as we started out with. All right, so what does that mean? Are all of these answers correct? Is one of them more correct than the other? I first want to examine student 4. They factored out 1/4. When you factor out a fraction, you're actually making the problem more difficult because you're dividing by a fraction, which is really multiplying by the reciprocal. So what student 4 did, I don't think any of us would attempt that. Okay, we don't factor out a fraction, we factor out a whole number unless what we're starting with is all fractions. All right, so taking student 4 out of um, this, looking at students 1, 2, 3, and 5, I noticed that students 1 and 2 factored out one common factor and left a trinomial, whereas students 3 and 5 factored out a common factor and then factored their trinomials into two binomials. So I would venture to say that student 3 and student 5 actually factored more. They factored more completely. So then if we evaluate what student 3 did versus what student 5 did, we see that student 3 factored out 4x, whereas student 5 only factored out x. And if you take a look at this second binomial in student 5's work, 4x minus 12, doesn't that still have a common factor that can be factored out? Isn't 4x divisible by 4 and negative 12 divisible by 4? They are. So we can say that not student 5, but student 3 factored this original trinomial completely. They factored until every single term for x, the binomial x plus 7 and the binomial x minus 3, none of those can be factored any further. So that's going to be the trick to factoring completely, is looking at what you did, not doing something, thinking that you're done and moving on to the next problem, but really looking at what you did and making sure that nothing else can be factored out of any part of your answer. Okay, factoring completely. Let's just make a quick little note here. Factoring completely is making sure that you cannot factor anything anymore. Okay, everything that you have is completely factored. You cannot factor out anything else. Okay, so this is a big idea. All right, so let's scroll down now. We have learned Xbox, and that has worked for us really, really well. We have also investigated some binomials and trinomials that are special. A binomial that is a difference of squares, and that factors a little differently, or a trinomial that is a perfect square trinomial, and that factors a little bit differently. Well, what we're going to look at now is some polynomials that have 4 terms. And when we have 4 terms, Xbox doesn't work. It's clearly not a perfect square trinomial, nor is it a difference of squares. So once we look and see that we have 4 terms, we need to use a process called factoring by grouping. Now, what we pretty much want to do with factoring by grouping is to look to see if our polynomial is written in standard form. Most often, I'm not going to say every single time because there's always exceptions in math, but most often, if your polynomial is written in standard form, you are going to have success factoring by grouping. So let's look at what we have here. A, is it written in standard form? X is our variable. Exponent of 3, exponent of 2, exponent of 1, and the constant last. This is in standard form. And let's look at B. We have 2 variables, x and y. If we remember, we have to have these in alphabetical order, okay, way back from lesson 1, I think. So x is going to come first, and we need to exhaust x going in decreasing order of the exponent before we get to a y. So we start with x squared, then we went to a y, and then back to x, and then our last term has x and y. We need to get this in standard form. Standard form is going to be our x squared first, then our x. Oops, forgot my plus sign. X squared plus x. Now we have to completely exhaust our terms with x in them. So now plus xy, and then the one with no x's at the end. So now this, what we've rewritten, is in standard form. All right, and when we go to standard, once we have these in standard form, we are going to group the first 2 terms together, and we're going to group the last 2 terms together. So for x to the 3rd power plus 3x squared plus 2x plus 6, that's our a. Oops, let me change the color. That's our a right here. We're going to take the first 2 terms and group them together and add it to the last two terms. So we have x to the third power plus 3x squared in parentheses plus 2x plus 6 in parentheses. And now we look for a greatest common factor from each pair. So I look and say, well, x to the third power plus 3x squared. I'm going to move over here and rewrite so I can show you my thinking. X to the third power plus 3x squared. And this is plus 2x plus 6. All right, so from this first binomial, we have x to the third power and 3x squared. I know that I can factor out x squared. X squared times what gives me x to the third power? X. And x squared times what gives me 3x squared? 3. All right, so now we're going to this one. Second binomial here. 2x plus 6. Is there a greatest common factor there? There is. It's 2. 2 times what is 2x? X. 2 times what is 3 is 6? 3. Excellent. Now what you'll notice here is that what's in our parentheses is exactly the same. And that's our goal when we're factoring by grouping. So once we have that the same, then we take the terms we factored out, those go together, and then just one of the x plus 3. And if we think of distribution, if we were going to multiply, this would be x times x and x times 3, or sorry, x squared times x and x squared times 3. And then this would be 2 times x and 2 times 3. Well, if we do the distributive property, it's x squared times x squared times 3, and 2 times x plus 2 times 3. It's exactly the same written in one step. So this is our final answer factor. Factoring by grouping. All right, now we're going to do B. I'll go back to my B color, which is green. We're going to take standard form, x squared plus x plus xy plus y. And we're going to split it up into the first two terms and the second two terms. Now we look for the greatest common factor of x squared and x. I can factor out x. X times x is x squared, and x times 1 is x. Now what can I factor out of xy plus y? Well, a y. Y times x is xy, and y times 1 is y. Did we get the same thing, the same binomial in our parentheses? We did. That's great. So now we rewrite it with our factored out terms in one binomial and whatever's in our parentheses as the other binomial. And we can see here we have the same answers. You will notice that our book wrote the answers just backwards from how I did. And that's perfectly fine because we know that multiplication is commutative. That means it doesn't matter what order we multiply. 3 times 5 is the same as 5 times 3. So it doesn't matter what order our binomials are in. All right, let's try one for practice. So on your own, let's do number 3. So pause the video, solve number 3, and then come back and check your answer. Pause now. Welcome back to the video. We have 3p to the third power minus 30 minus 5p squared plus 18p. My first question to myself, is this in standard form? It is not. So we're going to write it in standard form. 3p to the third power minus 5p p to the second power plus 18p minus 30. Now I'll split it up into the first two terms and the last two terms. Now I ask myself, is there a greatest common factor for 3p to the third power minus 5p squared? It is p squared. P squared times 3p will give us 3p to the third power. P squared times negative 5 will give us negative 5p squared. Now, what's my greatest common factor for 18p and 30? Well, it's not p because only one of those terms has a p. So 18 and 30, well, they're both even, so they must both be divisible by 2. But I'll bet there's something bigger. I think they're also divisible by 3. 18 is divisible by 3. 30 is divisible by 3. Is there a bigger number? 4? No. 5? No. 6? Yes. 6 times 3 is 18, and 6 times 5 is 30. So let's try that. We factor out 6. 6 times 3p equals 18p, and 6 times negative 5 equals 30. Did we wind up with the same thing in our parentheses? We did. Now, just a side note here. If you had taken that 18p minus 30 and you had only factored out 2 because you saw they were even, you would have 9p minus 15, and that would not have matched what was in your first parenthesis. So you know that's probably not correct. And then you would go on to try a bigger number. All right, so back to here, we take our factored out terms and put them in their own set of parentheses, p squared plus 6, and then leave our part that's in parentheses, 3p minus 5. And there we have our final answer. Okay, so we learned a new method of factoring. We have our Xbox method. We have recognizing difference of squares. We have recognizing perfect square trinomials. And then we have factoring by grouping when there are 4 terms. All right. Well, that brings us to factoring completely. Okay. When we factor completely, that means we cannot factor anymore. Nothing else can be factored, which means you cannot just factor once and stop. You actually have to think about what you are doing. If we scroll down to the next page, we have a concept summary. And this is really great looking at these guidelines to making sure your polynomials are factored completely. First, always factor out your greatest common factor. So look at every single term in your polynomial, see if there's a greatest common factor for all of those terms, and factor that out. If there's no GCF, then you don't do that step. Second, look for your special patterns, your difference of squares, or your perfect square trinomial, and factor that way. If there's not a difference of squares and it's not a perfect square trinomial, then try, if you have a trinomial, using that X box method and factoring that way, after you've checked for your greatest common factor, of course. If I don't want to circle the 4 here because it's not actually a fourth step. Its first step is GCF. Second step is look for special patterns, or 2A would be factor by Xbox, or 2B would be factor by grouping if you have 4 terms. So always take out the GCF, look for your special patterns. If there's no special pattern and it's a trinomial, factor using Xbox. If there's no special patterns and it's a polynomial with 4 terms, then factor by grouping. And each step of the way, check to see if you have something else. Very often, you'll factor out a GCF and then you'll have to use Xbox. Or you'll factor out a GCF and then you'll notice that you have a difference of squares. Okay, so every time look at each step and see if everything has been factored. All right, 3x to the third power plus 6x squared minus 18x, and we are going to factor completely. So I'm going to write it over here. This is A, and it is 3x to the third plus 6x squared minus 18x. Okay, is there a GCF? Well, you know what? I see an x in every single term. So I know that I'm going to factor out an x. Before I factor just my x, I'm going to check my coefficients and see if they have a common factor. 3, 6, 18. I know that they can all be divided by 3, so we're going to factor out a 3. So now I ask myself one step at a time. 3x times what equals 3x cubed? X squared plus 3x times what equals 6x squared? Well, 3 times 2 is 6, and x times x is x squared. Minus 3x times what is 18x? Well, no more x's, but 3 times 6 is 18. All right, so I factored out a GCF. Awesome. Now I'm going to look and see it's a three-term, it's a trinomial, so I'm going to check if it's a special trinomial. Is this a perfect square trinomial? Is x squared a perfect square? Yes, it is. Is 6 a perfect square? No, it's not. So this is not a perfect square trinomial, which means we need to check our Xbox method and see if x squared plus 2x minus 6 can be factored. So we have a times c, 1 times negative 6, and b, positive 2. Are there two numbers that we can multiply to get negative 6 and add to get 2? Well, usually I start by looking at factors of my top number, but when my bottom number is 2, there's only two ways I can add to get 2. 2 plus 0 or 1 plus 1. Neither of those are going to work for getting a product of negative 6. So then I know that this trinomial cannot be factored any farther, and all I had to do to factor completely was pull out the greatest common factor. 3x times the trinomial x squared plus 2x minus 6. All right, we'll choose a different color. And now we're going to do b. 7x to the fourth power minus 28x squared. b. 7x to the fourth power minus 28x squared. Well, when I see two terms and I see a minus sign, I automatically think difference of squares. X squared is a perfect square. X to the fourth is a perfect square, but 7 is not, and 28 is not. So let's see if we can factor out a greatest common factor first. 7 and negative 28, those both have 7 as a common factor. 7 times 1 is 7, 7 times 4 is 28. Awesome. And then I can also factor out the x squared. So at 7x squared times x squared is 7x to the fourth, and 7x squared times 4 is 28x squared. I have a minus sign. Okay, we have factored. That does not mean we're done because we're looking to factor completely. I pulled out a GCF. Can my binomial be factored any farther? Well, I notice it's subtraction. That leads me to think of difference of squares. Is x squared a perfect square? Yes, it is. Is 4 a perfect square? Yes, it is. So we keep our 7x squared, and then we factor this difference of squares into x plus 2, x minus 2. Every time you think you're done, don't be. Look back at every one of these. Can 7x squared, that's a monomial, it can't be factored. Can x plus 2 be factored any farther? No. Can x minus 2 be factored any farther? No. So then we can be confident that this is factored completely. Nothing can be factored any farther. We see the same answer from the publishers in our book. Okay, in yesterday's lesson, in lesson 7.7, we talked about the difference between solving and factoring. Remember, solving, we're going to have an equal sign. It's going to be an equation. And we always want it to equal 0. I'm just going to straighten this out a little. We always want it to equal 0. All right, so what are we given here? We are given 2x to the third power plus 8x to the second power equals 10x. So I'm going to come over here, 2x to the third power plus 8x to the second power equals 10x. Well, this does not say equal 0, and that's our first goal. So I'm going to subtract 10x from each side, and we're going to get 2x to the third power plus 8x squared minus 10x. I can't combine any of these terms because none of them are like. Their variables have different exponents. Now I can start factoring. We're still going to have an equal 0. Is there a greatest common factor? Well, I notice 2, 8, and 10 are all even, so I can factor out 2. And I notice every one of them has at least one x. So I'm going to factor out 2x. 2x times what is 2x to the third? X squared. 2x times what is 8x squared? 4x. 2x times what is negative 10x? Negative 5. All right, we factored out a GCF. I see a trinomial. Is it a perfect square trinomial? Nope, 5 is not a perfect square. So we're going to try our x box. We've got a times c is negative 5. B is 4. Two numbers that multiply to negative 5 and add to positive 4. All right, so our only factors of 5 are 1 and 5. Because this is negative, we're either going to have negative 1 and positive 5 or 1 and negative 5. If we're adding, this one gives us positive 4. So we're going to have negative 1 and positive 5. That's our x. Now our box. First term in the top box, and we're looking at this right here, x squared. Last term in the bottom right box, negative 5. These two terms in the other boxes with an x. Negative 1x is just negative x, and 5 with an x. And now we factor. Greatest common factor of x squared and 5x is x. X times what is x squared? X. X times what is 5x? 5. X times what is negative x? Negative 1. And always check the last one. Negative 1 times 5, negative 5. So that means this is going to factor into x minus 1 and x plus 5. We keep our 2x, x minus 1, x plus 5 equals 0. Remember, we're solving. So make sure we have factored completely. X minus 1 cannot be factored. X plus 5 cannot be factored. So we're good there. Now we're going to set every one of these equal to 0. 2x equals 0. X minus 1 equals 0. X plus 5 equals 0. Now we solve. Divide by 2. X still equals 0. Add 1, x equals 1. Subtract 5, x equals negative 5. So for our answer, x equals 0, 1, negative 5. Would have been better if I put the negative 5 first, but there you go. They put negative 5 first. Negative 5, 0, and 1. And notice that it says the roots. Okay, we're going to be talking about that so much in the next chapter. Roots, zeros, solutions. They're also x-intercepts. Roots, zeros, solutions, x-intercepts. All right. Finally, yes, this lesson is very long. We're taking 2 days. Um, Read the instructions in Google Classroom if you're not sure how this should work for 2 days. Hopefully, you've already done that. Modeling real life. A piece of equipment is submerged in the pool at the Neutral Buoyancy Laboratory for training. The piece of equipment is in the shape of a rectangular prism that has a volume of 72 cubic meters, a length of x meters, a width of x minus 1 meters, and a height of x plus 9 meters. Find the dimensions of the piece of equipment. Well, in first understanding, I know that I have a rectangular prism. I just used orange. Let's use something else. I'll use purple. I have a rectangular prism. Okay, so if we kind of sketch out this rectangular shape, it's going to look like that. Mine's a little crooked. It tells us that the volume of this equals 72 cubic meters. The length, okay, maybe right here, is x meters. The width is x minus 1 meters. And the height is x plus 9 meters. And we find volume by doing length times width times height. So we know that x times x plus 9 times x minus 1 has to equal 72. Great. Well, our entire goal, what are we trying to find? Find the dimensions. So our entire goal is to find out what x is, and then we can figure out what x minus 1 is and what x plus 9 is. Well, unfortunately, we can't solve it from this, what appears to be factor form, because we don't have equals 0. So we actually have to multiply this out. X times x, x squared, x times 9, 9x, x squared times x, x to the third, x squared times negative 1 minus x squared, 9x times x plus 9x, 9x times negative 1, no, sorry, back up, 9x times x is 9x squared, 9x times negative 1 is negative 9x, all equals 72. Combine like terms, x to the third power plus 8x squared minus 9x equals 72. We're going to subtract 72. So we have x to the third power plus 8x squared minus 9x minus 72 equals 0. Nice. How many terms do you have? 4 terms. How are we going to factor? Factor by grouping. Is it in standard form? X to the third, x to the second, x constant. It is. So we have x to the third plus 8x squared. Ooh, a minus sign. Yikes. Let's change it to plus and see what happens. So this is going to be plus a negative 9x and a negative 72. We'll see. Equals 0. All right. Factor from x to the third plus 8x squared. I'm going to factor out x squared. X plus 8. Factor. I'm going to factor out negative 9. X plus 8. Negative 9 times positive 8 equals negative 72 equals 0. So that gives us x squared minus 9 times x plus 8. Awesome. Factor by grouping. Just because you factored once doesn't mean you're done. I see a special pattern. I see a difference of squares. X squared minus 9 is the difference of squares. That's going to give us x plus 3, x minus 3, and x plus 8 equals 0. We set each of them equal to 0 and solve. So x could equal negative 3, x could equal 3, x could equal, oh, that's not minus 8, that's plus 8, negative 8. Only one of those is reasonable. X refers to the width of a box. It has to be positive, which means our width is 3 meters. Our, was that the width or the length? I think it was the length. So our length equals 3 meters. Our width is x minus 1. 3 minus 1, 2 meters. Our height is x plus 9. 3 plus 9, 12 meters. And if we checked and we did 3 times 2 times 12, that would be 6 times 12, which equals 72 cubic meters. So these are the dimensions of the rectangular prism on the ocean floor. Your assignment is in Big Ideas, lesson 7.2.